Alright, so in 7.2, we're dealing with some very different things. This one's a little strange, but it's kind of interesting. And we're excited to vote on plans for a new proposed thrill ride at a local theme park. The engineers who are called the Imagineers want public input for the design for the new ride. You are one of the 10 teenagers who've been selected to review the plans based on your good math grades. As your excitement mounts, the Imagineers begin the presentation. To your dismay, there are no models or illustrations of the proposed rides. Each ride is described only with equations. So, excuse me. The equations represent the path the rider would follow throughout the course of the ride. Unfortunately, your cell phone, which contains a graphing calculator app, is completely dead due to too much texting and surfing the internet. So you're trying hard to keep up with the presentation by trying to imagine what the graphs of each of these equations would look like. While each equation consists of functions you are familiar with, the combination of functions in each equation has you wondering about their combined effects. So you're going to recognize these. So what we're going to do is no graphing calculator, because you remember on the previous page it says it's broken, battery's dead, no graphing calculators. So no Desmos, we're just here. And I'm going to show you I have what I did before I got online, and those are kind of going to be the things we do. We're going to stay in radian mode all times, no degree mode, mostly because it's just better to do in a lot of ways. And so here we go. So the first one, so anyway, let's read our instructions. For each of the following proposed rides, use your imagination and best reasoning about the individual functions involved to sketch a graph of the path of the rider. Let y represent the height of the rider above the ground, and x represent the distance from the start of the ride. Explain your reasoning about the shape of the graph. Use radians for trigonometric functions. So anyway, so we're going to go ahead and start with a graph. I'm not worried about what it does in the past because, you're going to start at time 0. I'm just going to kind of quickly sketch each graph. So we've got, if we're going to call this one pi over here and pi halves. I'm going to sketch sine first. Sort of. It's not the greatest sketch, but I'm going up that high because the amplitude is 5. It's making this 5. And so the other graph line is going to do, so this is 1.5 and that's 3-ish. So at 3, 2x would be at 6. So it's a little bit like that. So it's doing that. So what would it do to my graph to add a line to a sine wave? And I thought about this one for a while, and I thought, well, maybe the sine wave will bounce around the line. So this is my imagination of the graph. So, and so I'm going to type my explanation, and I'm going to type exactly what I wrote before. The line will make the graph go up, and the sine will make it wave. So you'll notice I'm not being very clever or even necessarily precise in this explanation. I'm just kind of going, well, this is what I think is going to happen, and this is why. And when I first sketched this, I didn't look online. So this is kind of my idea, and you'll notice I put the red line as my midline, thinking that, well, maybe it will bounce around that. Who knows? I'm going to let you do proposal number 2 on your own. I think that one's a little bit more obvious. We have the absolute value in it, which means there can't be anything negative. Or in other words, this probably wouldn't be there. Whoops, not eraser. This probably wouldn't be there because, you'd have to do something else. So just kind of think about that one. Go ahead and imagine it. Draw it. Pause the video. Again, I'm not going to actually show you this one. Pause the video, see what you can come up with. for these next two, I also think the names of the rides, by the way, give away some of it. So like number 3 with the amplifier, knowing what an amplitude does, which is what gives it the height, the movement up and down is the amplitude. And so if this was 5, it would have a height of 5, but it has an amplitude that is changing. So the amplitude is getting larger, it's positive x, is getting larger as I go to the right. So the amplitude is getting larger. And I wonder what that does to the curve. And again, this one I'm not going to draw. I want you to try to think about it. I just know the amplitude is growing. So what would happen to my graph? I am going to do number 4 though. The gentle wave. So the gentle wave, we've got this exponential function here, which I recognize as exponential decay. And so, and why is it decay? So maybe you don't remember that word from when we were in Math 1, but because we've got a number smaller than 1 here, that means it's decreasing. So this would graph something like starting at 10, going down like that. So let's go ahead and do this one. This one starts at 10 and decays. And then we've got our sine wave doing this. So what do you think happens? And so what I thought, and I did this one on a different graph because it was kind of confusing to put on the same one, is that it would start tall and then kind of zero in on the end, start getting smaller. And my explanation, since the first graph is decay, I'm going to say getting smaller. That's definitely a smaller. The wave, the amplitude, and getting smaller and multiplying the sine wave, the wave will start with a large amplitude and gradually get smaller. And so that's my explanation. Now I'm going to give you a little hint here. I think that number 3 is the reverse of number 4. That's kind of a thought. It's my opinion. Okay. And then number 5 is actually the one I had the hardest time with. I tried to use the words and kind of think about it. My graph was totally wrong, but I am going to go ahead and sketch in what I have. And remember, this was totally wrong. But I know, okay, well, it's going to start at 100 way up here. And it says spinning high dive, but I also know it has to be sort of a function. So I'm like, and it's got this x squared in it, and I'm like, well, maybe it goes up and then goes and spins as it goes down. Because I wanted to get the wave into it, and I was like, and it's wrong. It's not even close to the right answer. So this is what I came up with, and I don't have a great explanation for it, because I was just like, well, I've got the start at 100, that makes sense, because if I plug in 0, the rest of these will be 0. So, like I said, this one matches the least. I want you to come up with your own version of this graph and understand that mine is wrong, and see if you can come up with something. And so, and then in our next video, we'll actually see what they really look like. So, good luck.